Give the title steam condensers. So can anybody tell what are the main components of a power plant? What are the main components? Boiler, condenser, turbine, and this one condenser. Okay. So don't say water pump, say feed water pump. Okay. That is a technical name for that. So what is a condenser? Condenser is a device in which steam is condensed to water at a pressure less than atmosphere. So there are two processes. Either there is a evaporation. So liquid water is converted into vapor, and reverse is that condensation. So vapor is converted into liquid. So that is condensation. Condensation can be done by removing heat from exhaust steam using circulating cooling water. So we use cooling water, we remove the heat from steam, and then steam is condensated to water. During condensation, the working substance changes its phase from vapor to liquid and rejects latent heat. So I think there is not enough space, but still I will try to draw. So we all know phase change diagram, right? So there is a temperature versus, let us say, entropy. What happens in phase change? Suppose there is a liquid water, its temperature is increased, and then there is a phase change. So latent heat is supplied. Again, the temperature can be increased. So this is a phase change diagram. Initially it was liquid, then it became saturated liquid, then it became saturated vapor, then it became vapor. So while going in this direction, we require latent heat of vaporization. But if you are going in reverse direction, what you need to do, you have to extract the heat, extract the latent heat of condensation. Okay. So by value wise, both are equal. यांच्या दोघांचे value same आहेत, but depending on the process, if you are converting liquid into vapor, so that will be latent heat of vaporization. If you are converting vapor into liquid, so that will be latent heat of condensation. Okay. Okay. So during condensation, the working substance changes its phase from vapor to liquid and rejects latent heat. The exhaust pressure in the condenser is maintained really 7 to 8 kilopascal. So it is below atmosphere. Okay. What is atmospheric pressure? What is the atmospheric pressure? What is the current atmospheric pressure? Can anybody tell? Huh? What is the problem? Huh? Anybody? What is the current atmospheric pressure in Pascal? Yes, Aditi. Anybody from online class? Huh? 1 bar. So atmospheric pressure is 101.325 kilopascal. 1 bar. How you said 1 bar? Huh? Kilopascal. And this is nearly equal to 1 bar. So it is nearly equal to 1 bar, but it is actually 101.325 kilopascal. Okay. Now, exhaust pressure in the condenser is maintained nearly 7 to 8 kilopascal gauge pressure. So it is not even absolute pressure, it is gauge pressure. So what is gauge pressure? Let us first understand that. So let us say this line is datum line and it is a atmospheric pressure. Whatever it is, atmospheric pressure. Okay. Now any pressure you measure above this is called as gauge pressure. This is called as gauge pressure. म्हणजे तुम्ही ज्यावेळेस टायर मध्ये हवा भरत जाता तर तुम्ही ते गेज ने चेक करता, ठीक आहे. दॅट प्रेशर इज गेज प्रेशर. एनी प्रेशर यू मेजर बिलो atmosphere, so this is called as vacuum pressure. This is called as, what is the spelling of vacuum? Not double C, CWM. Then CWM. Okay, don't give surprise look. It is there. I'm not telling lie. No, don't believe me. Okay. And then there is absolute pressure datum. So this is the absolute pressure, which is 0 Pascal. Means this datum is actually 0 Pascal, and whatever you measure above this, so this will be absolute pressure. If you go up to this, so this will be absolute pressure. If you go up to this point, so this will be again absolute pressure too. So please remember, gauge pressure is above atmosphere, vacuum pressure is below atmosphere, and there is another concept called absolute pressure. So if you measure with respect to absolute pressure, so what will be here absolute pressure at this point? Absolute pressure will be equal to what? It will be equal to atmospheric pressure correct, plus this much gauge pressure, plus gauge pressure. Okay. Now here it says it is maintained nearly 7 to 8 kilopascal gauge pressure. So it is very much nearer to atmospheric pressure. It is just 7 to 8 kilopascal above the atmospheric pressure, which corresponds to condensate temperature of nearly 330 Kelvin. What is 330 Kelvin? How much degree Celsius? So it will be 30, na? Array, simple math, minus 273. Huh? 40. Yes, 40 degrees Celsius. So at 40 degrees Celsius and 7 to 8 kilopascal gauge pressure. So at 7 to 8 kilopascal gauge pressure means how much absolute pressure? Can anybody tell? How much absolute pressure? How much? 9 point? Please tell me in kilopascal first. So 7 to 8 kilopascal gauge pressure. So how much is the absolute pressure? That is the question. So this plus this. So let us say 7 kilopascal. So 101.325 plus 7. So that will be 108.325. Okay, please remember this, very important. This will be absolute pressure. Okay, this will, unit will be kilopascal. And what will be the in bar? In bar, how much it will be? It will be 1.08 bar. Okay. There is a very good game is there, online game, Scribble. So you have to scribble. So you can play online also, multiplayer also you can play. So you have to just draw figures. Then other have to respond, and whoever respond in less time, he will be winner. Let us say I will draw a leaf like this. Then you have the one who will respond in less time, he will be winner. So if we get chance, we'll play that. Very interesting game it is. Okay. Okay. So write down this definition of condenser. Condenser is a device in which steam is condensed to water at a pressure less than atmosphere. And draw this diagram also for your understanding. Absolute, then atmosphere, then above gauge, below vacuum, and absolute will be this one and this one with respect to absolute datum. So write down the definition, this one, and draw this diagram also. Again, that atmospheric pressure 101.325. It is at sea level. Okay, 0 meter altitude, sea level. That at that point the pressure is 101.325. If you go above of it, pressure will reduce. Okay, so Pandharpur's elevation. How you can check elevation or altitude? You can anytime visit, or you can Google also, no problem. But when I used to in school, so that time our school teacher told us to go to check railway station. So if you visit any station in India, there the altitude will be given. So for Pandharpur, I think it is 463 meters. So as we go up from sea level, pressure will reduce. So at Pandharpur, pressure will be little bit less as compared to sea level. If you go in Himalayas, Sahyadri, again that pressure will be reduced. Oxygen content will be reduced. Aditi, or now what are the functions of condenser? The first one is to reduce the turbine exhaust pressure so as to increase the specific output, and increases the plant efficiency and decrease the specific steam consumption. So it means that as we lower the condenser pressure, the more work can be obtained. So that we have seen in how to increase the efficiency of a power plant. If you decrease the condenser pressure, the efficiency of the plant increases. Okay, if you remember. So it reduces the turbine exhaust pressure to increase the specific output and increase the plant efficiency. Then next is to condense the exhaust steam from turbine and reuse as pure feed water in the boiler. So this is actually the main function, to take the steam and convert it into pure water. Thus only makeup water is required to compensate loss of water. आता काय होतं कधी steam जास्त झाल्यानंतर wall मधून आपल्याला बाहेर काढावं लागते. There are some safety valves are there, pressure reduce valves are there, through which we have to take out some steam. So there is a loss of mass of water, and that can be again make up by using the makeup water. So this is the main function, and it enables the removal of air and other non-condensable gases from steam, hence improved heat transfer. आता काही कधी प्युअर स्टीम असेल असं काही नसते. सिस्टीम मध्ये काही कधी एअर बबल्स देखील असू शकतात. एअर किंवा पार्टिकल्स आपण ज्याला म्हणतो फॉरेन पार्टिकल ते देखील असू शकतात. कंडेन्सर मध्ये आपण दोन्ही रिमूव्ह करू शकतो. सो विथ रिमूव्हल ऑफ इम्प्युरिटी देर इज इम्प्रूव्ड heat transfer. So anybody not understood, I will draw that diagram. So this is a diagram ranking cycle. We previously known 1 to 2 to 3 to 4. Now in this case, if I reduce the condenser pressure or turbine exit pressure, what will happen? The new line will be like this. This will be point number 4 dash. So previously it was 4 dash, and new point here it will be 1 dash. So I am decreasing the condenser pressure. With decreasing condenser pressure, there is increase in net work output. So this hatch region here is a increase in net work done, and thus increase in efficiency. So reducing the pressure actually increases the work output. Now, what are the components of condenser? Elements of condensing unit. First is condenser. Second is air extraction pump. Third is condensate extraction pump. Fourth is cooling water circulating pump. Fifth is hot well. Then cooling tower, makeup water pump, and boiler feed pump. So we'll see in this diagram. So your understanding will be more clear. So this is a schematic of a condensing unit. Okay. So here C stands for condenser, B stands for boiler, ST for steam turbine. Then this is your boiler feed pump, BPF. This is hot well. This is makeup water pump. Then this is cooling condenser cooling water pump, and this is a cooling tower. This is air extraction pump. Okay. So see one by one, we'll see all the working. So what is the function of boiler? To provide the steam. What is the function of steam? To rotate the shaft of turbine, correct? Then here is outlet is steam. This steam is supplied to condenser. Okay. Now how steam will be condensated in condenser? For that we require a cooling water. Now from where cooling water will come? It will come from cooling tower. So cooling water will supply the cooling water to condenser. Here heat transfer will take place between cooling water and hot steam. Steam will be condensated to water. Now whatever air and other impurities are there in the steam, these are being removed with the help of air extraction pump. So this is AEP is there. It removes the air from the steam. Now here condensated water is being extracted with the help of condenser extraction pump. So this pump will extract this condensate and it will supply to hot well. Hot well is a temporary reservoir in which water is stored, and from this hot well, water is taken by boiler feed pump and it is pumped to boiler pressure. So function of boiler feed pump is to pump water from condenser pressure to boiler pressure. Then this high pressure water is supplied to boiler. Okay, so draw this diagram. Did it? Okay. Now see here, this is a cooling tower. If I want to draw a detailed diagram of cooling tower, it would be like this. Then this hot water from condenser, it is supplied from at top and it is sprinkled actually. It is sprinkled like this. Okay. Then there are air inlets at the bottom from which air is passed. These are the air inlets. And then there is this fan at the top. This fan at the top. What will happen? Fan, when we start the fan, there will be air circulation will be generated. So air from outside, this is actually air. Air will come inside and it will go from top. Okay. So again, air will come from bottom and it will go from top. So in between what happens? There is a heat exchange between air and water. Okay. Now because of heat transfer, this water temperature actually reduces and this water is collected at the bottom. Okay. And this is a cold water. But what happens when air is moving in upward direction? It takes some water moisture with it and there is a reduction in mass of water. जैसे air वर जात असते त्यात थोडे particles ते बाहेर घेऊन जाते. So that is why there is a loss in mass of water. In order to cover that loss, we are using a makeup water. We are using a makeup water. बरेचसे हे जे न्यूक्लियर पॉवर प्लांट तुम्ही बघितले तर ते समुद्राच्या किनारी आहेत. त्यात एक फॅक्टर आहे की इन केस एक्सप्लोजन झालं तर काय हानी होऊ नये. And another purpose is to use the makeup water. समुद्राचं पाणी फुकट आहे and it is available in abundant amount. So it is used as a makeup water and it is supplied to cooling tower. So have you written all these components? Huh? One day what we'll do, we'll make you sit with Dakshata and you will learn from Dakshata how to take notes in half time. Okay. Next is classification of condensers. Okay. Now main category, there are some categories. Categories according to type of flow. So parallel flow, counter flow and cross flow. So what is this? I will show you. This is actually in the subject heat and mass transfer. There also you will study no problem, but now also I will show you. So first is parallel flow. In parallel flow, what happens? I will show you. So there are two pipes, as you can see, or two fluid streams. One is this, which passes through inner pipe. Another is there two, which passes from outside. So in parallel flow, the direction of both the fluids is same. So this is a parallel flow heat exchanger. Now counter flow, as you might have already guessed, counter flow. In counter flow, the inner fluid, if it is moving in forward direction, the fluid number 2 will move in backward direction. So there is heat exchange takes place at these boundaries, at these surfaces. And third is cross flow. Cross flow is like this. So there is a fluid which is flowing in forward direction. And there is a, let us say, air which passes in cross direction. Not through these pipes, but it passes on through the pipes, on the surrounding of pipes. This is a cross flow reduction. Okay. These are the three types: parallel flow, counter flow, and cross flow. Okay. So according to type of flow, parallel flow, counter flow, and cross flow. Now next is according to the cooling action. Okay. According to cooling action means there will be direct contact between steam and water. So that is called as jet condenser, or there will be no direct contact, indirect contact will be there between steam and water. Like in this case, there is no direct contact, steam is flowing from inside pipe and water is flowing from outside pipe, and there is no direct contact. So heat transfer will take place through surfaces. In jet condenser, direct mixing of steam and water will be there. Okay. So we'll see one by one jet condensers. Okay, have you written this previous according to the cooling action? So write down jet condensers and surface condensers. According to the cooling action, okay, write only two names: jet condensers and surface condensers. Now in that first one, jet condensers. So in jet condensers, exhaust steam from turbine and cooling water from cooling tower come in direct contact and mix together. Thus the final temperature of condensate and cooling water leaving the condenser is same. म्हणजे यामध्ये काय होतंय, जे स्टीम येते आणि जे कुलिंग टॉवर कडून कुलिंग वॉटर येते त्याचं डायरेक्ट मिक्सिंग होते. देयर इज नो indirect, sorry, it is a direct mixing. A jet condenser is very simple in design and cheaper. It can be used when cooling water is cheaply and easily available. In case of sea, etc. Condensate cannot be reused in boiler because it contains impurities like dust, oil, and metal particles. आता काय होतंय, आपण डायरेक्ट मिक्सिंग करतोय, स्टीम मध्ये ऑलरेडी इम्प्युरिटीज आहेत, like dust, oil, metal particles. ते आपण डायरेक्ट मिक्सिंग करतोय कूलिंग वॉटर बरोबर. So we cannot directly use it for boiler. Again, filtration has to be done, and after filtration we can use it in the boiler. So that is the drawback of jet condenser. So there are some types, we'll see one by one. So low level parallel flow jet condenser. Okay, so this is a diagram for it. So cooling water comes from one direction at the top. Exhaust steam comes from top. So this comes from lateral direction. This comes from top direction. These are mixed together. So there is a direct contact between the particles of steam and water, and these are mixed together. Then eventually steam is condensated, and then we get the water at the bottom. Then there is a wet air pump. So from this air is extracted, and condensated water is collected at the bottom. Okay. Very simple construction, low level parallel flow jet condenser. Okay. So give the name and draw the diagram. Very simple diagram is wet air pump is used to extract the mixture of condensate, air, and coolant. Vacuum created is up to 6 kilopascal. Draw the diagram. Okay. Next, low level counter flow jet condenser. So previously it was parallel flow. So water was going in downward direction, steam was going in downward direction. Now next is counter flow, low level counter flow jet condenser. Okay. So in this case, first figure is parallel flow. So previously what we draw, you draw. So this is a simple, this is the actual or schematic of parallel flow heat exchanger, condenser. So in this case, exhaust stream was coming from top, water is coming from top. These are mixed together, both move in parallel direction. Now opposite to that, we have here counter flow. In this case, as you can see, exhaust stream comes from bottom, it moves in upward direction. Water comes from top, it moves in downward direction. So there is a counter flow, and heat exchange takes place. Water is condensated, it is collected at the bottom. There is this extraction pump which will extract this water. It is supplied to hot well. From hot well, water will be supplied to boiler. Some part or some water is again collected in cooling pond. From cooling pond, cooling water is collected. Okay. So this way the cycle will be there. This is a parallel flow and this is a counter flow. Now in this case, how this water will flow, how this water is flowing? Huh? Not cross, how? So there a pump should be required. So in this diagram it is not shown. How the water will move against gravity, it is not possible. So again a pump will be required here. So they say the pump for water supply is required if it is to be lifted more than 5.5 meter in height. So anyway pump will be required for the lifting purpose. Which one you are drawing? Huh? Asbay, which one you are drawing? Are you out of your sleep? Huh? बरं नाही का? अच्छा. So in online, they will give directly diagram. They will ask you which type of it is, parallel flow, counter flow. Okay, completed. So draw the free body diagrams. Don't use scale and all. Your diploma students already, the perfection will be there in your hand. एवढं परफेक्शन पाहिजे की स्ट्रेट लाईन झाली पाहिजे ते बरं असं मागपुढे आलं नाही पाहिजे This is a animation, short animation is there for counterflow condenser. Again, you can see steam is coming from downward direction, water is coming from upward direction. The counterflow heat exchange takes place. Condensed water is collected here. There is an extraction pump. Will extract the water supplied to hot well from it to boiler. Some water from hot well is collected at cooling pond and then it is pumped to condenser. Okay. I don't draw this. Now this is a special type of counterflow condenser in which the height of condenser is greater than that of atmospheric pressure in water column, that is 10.33 meter. So many of you may have forgotten up to this point, but let me remind. So previously we have seen what is the 1 bar pressure, okay, or 1 atmospheric pressure. So 1 atmospheric pressure is how much? 101.325 kilopascal. In other words, we have other units like gauge of water or gauge of mercury. It is also 760 mm of mercury. 1 atmosphere is 760 mm of mercury, or it is also 10.31, or here in this case 10.33, but it is 10.31 meter of water gauge. 10.31 meter of water gauge. Have you heard of this 760 mm? Huh? 760 mm of Hg is 1 atmosphere, or 10.31 meter of water gauge, it is equal to 1 atmosphere. Okay. So when the height of this unit is above this 10.31 meter, in that case we go for high level jet condenser. In this case, a pump is required, injection pump is required to pump water from this pond to condenser. Okay. Otherwise, remaining so if you compare with previous diagram, here there is no extraction pump is not there. So previous cases, if you remember, there was extraction pump was there at the bottom. In this case, there is no extraction pump, and previous cases there was no supply pump here, but in this case there is a injection or supply pump is there. Okay. So draw this diagram also. Another detail in this case is there is a baffle is provided, baffle plate is provided. So when the water will fall on the baffle plate, it actually creates a sprinkle, like water falls in small droplets through this baffle plate, and then the heat exchange will be more. Now very good aptitude question is there. Okay, suppose there is this water bubble is there. Okay, and it has a radius r. Okay. Now this sphere, actually it is a sphere. Okay, water bubble means it is a sphere. Now I have cut this sphere into half and I have created 2 more spheres. Like coconut. Okay. What will happen to area? Previously, let us say area of sphere was A. Let us say this was area is A1. This is area A2. A1 plus A2, let us say it is B. So A and B will be equal more or less. Huh? Check. सो व्हेरी कॉमन क्वेश्चन, एक मोठा स्पियर आहे, वॉटर बबल आहे किंवा कोकोनट आहे, काय पण असेल. कोकोनट अजून पोकळ असते, पण हा सॉलिड स्पियर आहे, तो मी मधून कट केला, त्याचे दोन भाग झाले. व्हॉट विल हॅपन टू द एरिया, सरफेस एरिया? check what is the formula for area of sphere? What is the formula for area of sphere? 4 pi r square. Okay, okay, write down 4 pi r square. What is the area of half sphere? Two pi r square plus this area, pi r square. So previously area was 4 pi r square. In this new area will be this 2 pi r square, 2 pi r square plus pi r square plus pi r square. Okay, so in this new case, area will be 4 pi r square plus 2 pi r square. Sorry. Okay. So what we learn actually, why I'm telling you this, what we learn from this? So as we divide bubbles into or droplets into smaller droplets, the surface area increases. As the surface area increases, the heat transfer increases. So you might have studied in IC engine, fuel injection. Have you studied? In fuel injection, what we do, we create a spray. डायरेक्ट ते आपण फ्युएल काय होतच नाही इंजिन मध्ये आहे असं, तर आपण त्याचा स्प्रे तयार करतो. स्प्रे मध्ये काय होतं, द लिक्विड ड्रॉपलेट इज ब्रेक इनटू थाउजंड्स ऑफ स्मॉलर मॉलिक्युल्स और स्मॉलर ड्रॉपलेट्स, आणि जेवढं मॉलिक्युल ड्रॉपलेट जास्त तेवढा सरफेस एरिया जास्त होतो. दॅट वे हाय heat transfer can be achieved. Okay. Similarly, here we have a baffle plate. Baffle plate मधून वॉटरचे ड्रॉपलेट्स म्हणजे असे धार तयार होते, and then heat transfer is more. Okay. Understood everybody this concept, splitting of sphere? This is another animation for this high level jet condenser. There is no extraction pump here, directly water is falling in the hot well. But to pump water from hot well or cooling pond to condenser, we require a pump. So this is the animation for the high level jet condenser. This is the last type of jet condenser. This is called as ejector condenser. This is called as ejector condenser. So it is actually a parallel flow condenser. The cooling water comes from top, the steam comes from lateral entry. So please first understand the concept. Then there are these structures are like this, which forces water into center, which forces water, whatever steam is coming, forces steam into the center. Then the heat exchange takes place, and then water is condensed. So main objective here it is to increase the surface area. Okay, if you see the cross section of an ejector pump, so this way cooling water is coming, this way exhaust steam is coming, and with the help of this structure, these are two forced together in the center, then heat exchange takes place, and then we get a condensated water. So moment of flowing water is used to remove the mixture of condensate and coolant from condenser without the use of any extraction. So draw this diagram. So as we increase the momentum towards the center, there is no need for extraction pump. At the entry of this steam, there is a non-return wall. That means steam cannot go in the backward direction. Non-return wall means only it will move in the forward direction. Okay, this is the cross section. You can check here. Steam comes from lateral entry, water comes from top. There is a structure process both at the center. Then we get a condensate water at the bottom. So what are the advantages and disadvantages? Advantages: simple in design, it is cheaper in cost, and less floor area is required to take the heat transfer between steam and water. Disadvantages: condensate is not pure because there is a direct mixing, there may be impurities. And secondly, low vacuum efficiency. What is vacuum efficiency? We'll see later. For time being, you write down these advantages and disadvantages. In next lecture, we start surface condensers. And in next lecture, this chapter will be finished. It's a short chapter, theoretical only. Okay, so with this, we'll stop here. Please put your attendance in the chat box. Next lecture, we'll start the surface condenser.